Hello students, myself Shrimati Bhosle SS from MDS College Srigonda, and we will be studying chapter number 9, coordination compound. This is the third lecture, and in this lecture we will be covering the topics IUPAC nomenclature of coordination compounds and effective atomic number rule, that is EAN rule. So let's begin. So the first topic is the IUPAC nomenclature of coordination compounds. So let's see the rules which are used for naming the coordination compounds. The first rule is that while naming the complex ion or neutral molecule, name of the ligand is written first and then that of the metal. So name of the ligand is written first and then the name of the metal is written. Second rule is that the name of ionic ligands are changed from IDE to O and ATE to OTO. So the name of ionic ligand suffix IDE is changed to O, and the suffix of the ligand having the suffix ATE is changed to OTO. The third point is that the name of the complex ion should be written as a single word with no space between the name of ligands and the name of metal. So the name of the complex should be written as a single word. Next, fourth point is oxidation state of metal is written in parenthesis, that is in bracket, after the name of the metal without any space. So while writing the name of the complex, the oxidation state of the metal is to be written, and it should be written after the name of the metal, and that also in bracket. Fifth point is that if more than one ligand of same type is there, then the prefix like di, tri, tetra are used. So if more than one ligand of the same type are there, then their name is written by adding the prefix di, tri, tetra and hence on. If more than one type of ligands are there, then they are written in alphabetical order. So if the complex is having more than one type of ligand, then the priority of ligand is written on the basis of their alphabetical order. The seventh point is that if the name of ligand itself contains numerical prefix, then their number is displayed as bis for true, tris for 3, tetrak is for 4, and ligand name is put in parenthesis. For example, ethylene diamine. Now the word ethylene diamine, the name of the ligand itself has di in its name. So, if when this ligand is used, for example, ethylene diamine, it is written in short form as En. And if three molecules of ethylene diamine are attached to a metal, then while writing the name of this ligand, it is written as tris and the name of ligand is written in bracket, that is ethylene diamine. Okay, so tris is the number of ligands which are attached to the metal. Here it is written. The next 8 point is that metal in cationic or neutral complexes is specified with usual name, while in anionic complexes name of the metal ends with ATE. So if the complex is cationic or neutral, the name of the metal is not changed. But if the if the complex is anionic, the name of the metal is changed and it ends with ATE. Moving on to the forward, this is a chart containing IUPAC names of anionic and neutral ligands. So let's go through it. The anionic ligand bromide, its IUPAC name while writing the name of the complex is written as bromo. Chloride, chloro. Fluoride is written as fluoro. Iodide is written as iodo. The rule which was stated, second rule, that the IDE, here you see the IDE is changed to O, suffix O. Sulfate, ATE is changed to ATO, that is sulfate is changed to sulfato. Nitro is changed to nitrato. Carbonate, carbonato. Hydroxide, hydroxo. Oxalate is written as oxalato. Nitrite is written as nitro if the bonding is through nitrogen. If nitrogen is donating its lone pair, then the ligand is named as nitro, and if the oxygen is donating its lone pair, then the ligand is named as nitrito. Thiocyanate, again if the donor atom is sulfur, then it is thiocyanato. If donor atom is nitrogen, it is isothiocyanato. Let's name some neutral ligands. Ammonia is written as amine, where your AMMINE, so double M is written. Carbon monoxide is written as carbonyl. Water is written as aqua. Ethylene diamine is written as ethylene diamine only. Moving forward, now this is the table containing IUPAC names of metals in ionic complexes. We have seen in the last point that the name of the metal in a cationic complexes changes to ATE. So aluminium becomes aluminate, cobalt becomes cobaltate, gold becomes aurate, manganese becomes manganate, platinum becomes platinate, chromium becomes chromate, copper becomes cuprate, iron becomes ferrate, nickel becomes nickelate, and zinc becomes zincate. Now let's see some examples, and using these rules we will write the IUPAC names of some complexes. Now the first complex we will be taking as the anionic complex. This is the example NiCN4 having the charge -2. So let's here cyanide is carrying, each cyanide is having one negative charge. So the oxidation state of nickel in this complex is +2. Okay, now we have seen that name of the ligand should be written first, and there are 4 cyanide ligands, so it will be tetracyano, the anionic complex. So nickel name will be changed to nickelate, and oxidation state of nickel is 2. So the IUPAC name of this complex is tetracyanonickelate 2 ion. 2 is the oxidation state of the nickel. Next example of cobalt, COC2O4 thrice having the charge 3 minus. Now we know oxalate is carrying 2 minus charge. Oxalate ligand is carrying 2 negative charge. So oxidation state of cobalt in this complex is +3. Oxidation state of cobalt in this complex is +3, and 3 molecules of oxalate is there. So it will be trioxalato. So let's write, and since it is anionic complex, the name of cobalt will be written as cobaltate. So let's write the name. The name will be trioxalato cobaltate 2 ion. Okay. Next, the let's see the example of the compound containing complex anions and metal cations. Now this is the complex Na3CONO2 6. Okay. Now here this complex is anionic. It is carrying a negative charge which is balanced by 3 sodium ions. So the complex as a whole is neutral, but your coordination complex is negative, carrying a negative charge. Your nitrite is NO2 is carrying -1 charge, and so cobalt in this oxidation state of cobalt in this complex is +3, and this is cationic complex, so name of the cobalt will also change. Sorry, this is anionic complex, name of the cobalt will change to cobaltate. So let's write. First will be name of sodium will be written. So the name of the complex will be sodium hexanitro cobaltate 3. Sodium hexanitro cobaltate 3. Moving to the next example of the cationic complexes. This is the example Fe H2O5 molecules NCS, that is isothiocyanate, carrying complex is carrying +2 charge. Now the oxidation we know NCS, that is sodium isocyanate, is carrying one negative charge. So the oxidation state of Fe in this complex is going to be plus 3. And it is a cationic complex, so name of the Fe will not change. So let's write the name of this complex: pentaequo isothiocyanato iron 3 iron. Okay, now here two ligands are there, isothiocyanato and your aqua. So aqua will be written first and then isothiocyanato, using the rule that the ligand should be named as alphabetically. Okay, now moving to the next type, that is compound containing complex cations and anions. Example is CONH3 5 CO3Cl. Now here the complex is cationic, that is the complex is carrying a plus 1 charge, which is balanced by your chloride, which is outside the coordination complex. So cobalt carbonate, we know it is carrying minus 2 charge. So cobalt, oxidation state of cobalt in this complex is plus 3. Okay, and this is cationic complex, so the name of cobalt will not change. So let's write the name: pentaamine carbonato cobalt 3 chloride. Now here name of amine is written first and then the name of carbonate is written, using the rule that name of the ligand should be written in alphabetical order. Now neutral complexes, let's name some neutral complexes. This is the example FeCO5. So here the oxidation charge carried by the carbon monoxide is 0. So oxidation state of Fe in this complex is 0. So let's write the name: so it will be pentacarbonyl ion 0. Okay, so these were the some examples where we name some of the coordination complexes using IUPAC nomenclature. Moving to the next topic, that is effective atomic number rule. Now the stability of the complexes, that is the coordination complexes, was proposed by the scientist, that is Sidgwick, and he made some rule. He proposed an empirical rule which was known as effective atomic number rule, that is EAN rule. Now this rule is nothing, that it states that EAN is nothing but your total number of electrons around a central metal ion in the complex. So basically your EN rule gives the number of electrons which is surrounding the central metal atom in the complex. It states that the metal continues to accept electron pair till it attains the electronic configuration of nearest noble gas. So we know that from the definition of coordination complex, that the central metal ion is electron deficient, that is it is acting as a Lewis acid. So it continues to accept the electrons from the ligands until it reaches the configuration of nearest noble gas. So the nearest noble gas, that is if En is 18, that is that of argon, 36 that is of krypton, 54 that is of xenon, and 86 that is of radon, then the EAN rule is obeyed. Now EAN is given as number of electrons of metal ion plus number of electrons donated by ligands. So let's write the formula. EAN is equal to atomic number of metal, that is Z, minus number of electrons lost by metal to form ion, that is X, plus number of electrons donated by the ligands. So EAN formula can be written as EAN is equal to Z minus X plus Y. Your Z is atomic number of the metal, X is the number of electrons lost by metal to form ion, and Y is the number of electrons donated by the ligands. So let's do one example of cobalt CONH3 6, and the complex is carrying plus 3 charge. That is, we know that ammonia ligands are neutral ligands, so the charge of the complex is nothing but the oxidation state of the cobalt, that is plus 3. So Z is 27, that is the atomic number of cobalt is 27. Since it has lost 3 electrons to form the ion, so X is equal to 3. And there are 6 ligands of ammonia. Ammonia being a monodentate ligand, that it will donate, one ammonia will donate 2 electrons. So there are 6 ammonia ligands, so 6 into 2, that is equal to 12. So value of y is 12. Substituting the values, we get z minus x plus y, that is 27 minus 3 plus 12, that is equal to 36. So cobalt in this complex follows the EAN rule. So complexes like CrCO6, FeCN6 4 minus also obey EAN rule. But there are certain compounds which do not obey EAN rule. Let's have the example FeCN6 with the charge 3 minus. Now here Fe, atomic number of Fe is 26. Cyanide we know is carrying minus 1 negative charge, so oxidation state of Fe in the complex is plus 3. So it has lost 3 electrons, so X is equal to 3. Cyanide we know is a monodentate ligand. One cyanide will donate 2 electrons, so 6 cyanide will donate 6 into 2, that is 12 electrons. Substituting the values in Z minus X plus Y formula, it will be 26 minus 3 plus 12, that is 35. So it should have been 36 in order to be, in order to obey the EAN rule. So even though the EAN is 35, the complex is stable. It is not following EAN rule, but then also the complex is stable. Now next example, MnCO5. Here atomic number of manganese is 25. Carbon monoxide is a neutral ligand. So oxidation state of manganese in this compound is 0. So no electrons is lost to form ion, so X is 0. Each carbonyl is going to donate 2 electrons. 5 carbonyl ligands are there, so 2 into 5, 10 electrons will be donated by ligand, so value of Y is going to be 10. Substituting in the formula, you get 26 minus 3 plus 12, that is 35. So again this complex is also not obeying EN rule. We are getting the value as 35, but then also this complex is stable. So with this we come to the end of this lecture. Thank you.